Thank you. And I want to thank you all for this great opportunity for me to join us. And my name is Yu-Feng. I'm a hydrogeologist from Illinois Geological Survey, and we located on campus here. So I'm neither computer scientist nor GIS scientist. So I'm a hydrogeologist. So today I want to share with you is from the point of view from a user instead of developer or a GIS scientist. And the title I have here, actually what I want to share with you is not the things I have done. It's the things I would like to be doing, or the development I'm planning ahead to following your lead, following your development in the CyberGIS. Okay, so you are a very different group than what I am used to present, talk to. So my approach will be a little bit different than the way I talk to my folks in hydrogeology. So I'm going to stick on this slide for 5 minutes, so don't panic, okay? I know I only have 10 minutes, okay? So the reason I'm going to stay on this one for 5 minutes because there's some information I want to extract from this simple slide here, okay? I think 10 minutes I can tell 3 stories. So I only going to tell 2 stories here. But first, before I tell any story I'm not going to repeat the title, but groundwater surface water interaction is so important in our community. The reason for that, it has been identified by National Research Council from the geology group, hydrology group, climatology group for the last 2 decades. Okay, and because it reflects a lot of important components for the whole hydro cycle, which also related to climate change for the energy problem. So that's why this is a problem I've been tackled for the last 10 years. And I've been a principal groundwater modeler for the northeastern region of Illinois, which including Chicago metropolitan area. My group, we have developed regional model covering 4 states and also Lake Michigan. Try to understand groundwater resource in this region, okay? So, first story is this. 7 years ago, I got a grant, 4 years, $2 million to develop this big model. And my model, I use cluster. It takes me 2 weeks to calibrate a steady state model. And my transient model, it takes 1 week to run one single simulation. And then I deliver the result, the stakeholder, and also the state decision maker. They are so happy to see this. Wow, this is great. We've never seen anything like this. This is going to be tremendous help for our future planning. Okay, I was happy. They were happy. 1 year later, I went to one of their office and say, hey, what have you done with my model? You like it, right? Oh, yeah, but we haven't got time to really work on it yet. Okay, a year later, that means two years after I delivered a model, what have you done with my model? Not much. They are still looking at the paper report that I delivered. I also delivered 3 DVDs with them, okay, with all of the shape file and also my modeling results, okay? And they just, we don't know how to use it. But the results still look good. Thank you very much. But for me, it's really unsatisfying, okay? I'm not just developing that for the next project, okay? I want this to be useful. So this is story number 1 there. We see there's a gap between our scientific result to the decision maker and policy maker. And that's one of the roles we are playing here as a state geologist here. So our unit, basically, we have the luxury to work with faculty members on campus to collaborate on research and teaching. We also answer the questions from general public and also stakeholder, decision maker, policy maker. Okay, that's where our role is. So the second story is 5 years ago, we got a phone call from the Chicago city planner say, can you give me the information about the water resource sensitive area for the city development? When I got a phone call, I said, what is that? Then I think about it. Okay, what he is asking is the recharge map. Recharge map, which means groundwater surface water interaction. I said, sure. When do you need it? Oh, this afternoon. I said, forget it. I need 6 months to do this. Okay, so there's still a need, an urgency need, a gap between decision maker and our result there. So next slide, 5 minutes. Okay, so then we just do kind of experiment last year, and a student and we just developed a simple tool for their purpose. What we develop is not really for you, it's for them. Just like what David developed, David Manman developed Archhydro. It's really important in our community, but that tool is for me. It's not for the decision maker or the policy maker who is not technical savvy person there. So this is a slide I show them. I'm not intend to show this to you. So this is a slide I show them. Say right now we develop a tool, and then the purpose is this. And then we use the free software, and when I say free, they got their attention, okay? And then I want this to be able to deliver my result to you within 5 clicks, and then you can have it within sub-second to show this result. And they said, really? I said, yeah, it can show the information you want from your backyard based on my simulation. And then it can be genetic enough. You can have overlay different informations and see how much drawdown from pumpage and how that impact into your wetland. And basically it's just a query, right? In GIS, very simple things. So we just use an earlier version of ArcGIS Explorer and put some functions, query in there. And the design, they can have their result within 5 seconds. The decision maker, policy maker, they can use it by their own fingers. And then I just show them those examples. We can switch to different data set. And later on, we even put a function in there, an analytical solution. When you have a pumpage, what's the impact area for this new pumpage? Okay? And I told them again, this is free. You don't need to wait for 6 months. And maybe I was imaged, but I almost see some people with their tear there, you know. And they can really operate on this based on my modeling results. So this is kind of, for you, you might think, well, this is very simple things. But for them, it's something they can really use without really extensive training. And then for them to kind of simulate, oh, what can I use this scientific result to help my planning part? So it was kind of experiment for us. See, well, can we use this and to do more, oh, where am I now? To put more scientific features and following what you are going to develop in the CyberGIS. And even that tool, that simple tool, the user write a review paper in one of our top journal to share their reviews. See how important to have a tool like this for us to reach our decision maker and policy maker there. So now this is I'm not here to tell you what to do. I mean, who am I to tell you what to do? But I'm here to tell you what do we need from this group, okay? So what we have envisioned is if there's a CyberGIS can really help us to integrate 3 major components: multidisciplinary data, rapid modeling results, and real-time observation. We'll be really happy to have this platform, and also with not just steady state map, but also with time scale, multiple time scale, and also spatial scale on this. So this diagram might look very busy, but I'm happy to break down a little bit easy because that's the plan. That's the task we are working on right now. So for example, like this one, data. I mean, we have a very heavy group working on GIS in our survey. I mean, our surveys, we have 5 surveys in this institute, and we are probably the largest GIS working force in the state. And fortunately, the section head, Mark Yakushi here, is also here. And his group is huge, it's tremendous, working on the data set, making the data set to be accessible to everybody. This one, I mean, we are trying to adapt GPU computation into groundwater modeling. That's one of the projects we are working on right now. And this one, we are using fiber optic device, try to measure temperature continuous in time and space to understand groundwater surface water interaction. So those three components we are working on right now. I have a mechanism to let these two, and these two, every two of them talk to each other. I have no problem to do that. But in order to make all of them talk together to be more efficient and then to help us to understand more about science and then to deliver decision maker and policy maker, we need your help. So basically that's what I want to share with you. And this is just one example how we connect them together. And if you build it, we will come. Thank you.
Let's thank all our lightning speakers. That was a great session, very interesting talks.